Hello, welcome to part 2 of the 8th grade EOC or state exam or even final exam. So let's begin. Okay, so here I have a rectangle, all right, and it says for the rectangle shown, which equation can be used to find the value of x? Okay, so I'm taking a look at the shape here, and I'm also taking a look at the answer choices. And this looks to be a Pythagorean theorem problem. So let's go ahead and write down the formula for the Pythagorean theorem, which is a squared plus b squared equals c squared. And we're actually not solving this. We're actually just determining which equation can be used to find the value of x as it's stating here. Okay, so we can recognize that this is a right triangle, right? And then we know that this is Pythagorean theorem because we have a hypotenuse of 10, which is across from the right triangle. We have that value of 10 here. So we can conclude that this is A, this is B, and this is C. So let's go ahead and plug in our values to determine which equation is the correct one. So we have a squared, which we said is 6. So that's 6 squared. Plus, and then we can say that this is x squared because we're looking for the value of x and x is in place of b. And then this is equal to c squared, which is 10 squared. So taking a look at the answer choices, we can eliminate choice A because this is not Pythagorean theorem and this is not set up to find the value of x, right? So because we have the quantity x plus 6 squared is equal to 10 squared. What about B? 6 squared plus x squared equals 10 squared. Well, bingo, that's the answer. However, let's continue determining what these are and if it makes any sense. So we have 6 squared plus 10 squared equals x squared. So be careful with this one. I can see how someone can get tricked with this one because this is a squared plus c squared is equal to b squared, right? And that's not the formula for a Pythagorean theorem. So this can be crossed out and is also, and although you can find the value of x, that's not the correct formula. And then for letter D, we have 6 plus 10 equals x squared. Well, we're not adding the two values together, right? So this is unreasonable. So the correct answer is answer choice B in this instance. All right, so let's move right along. So for this one, we have a composite figure. So there are more than one shape in one shape here. Okay, so we can actually break this apart, and I'm going to extend this out further. I can make one large rectangle here. Okay, so that way we have two shapes so far. We have one large rectangle and we have a triangle. And so since we have to find the area, we are going to place our formulas up here. So we have the area of a rectangle, which is length times the width. And we have the area of a triangle, which is 1/2 the base times the height. Okay, so far that's what we're looking at. So now let's go ahead and see what we can do to solve this. So right now I'm looking and I see that I have a length here and I can actually have a width here. So I can actually turn this into one additional rectangle to make it easier. So let me go ahead and outline this. And extend this further down here. So this is one rectangle. So that's another rectangle. So let me go ahead and add another area here for rectangle, which is length times the width. Okay, and then let's go ahead and make some additional changes. I can see that I can bring this 2 up here. So we have 2 centimeters here for our width on this rectangle. And then let me just go ahead and extend that down here as well. So we have 2 centimeters here. And then we have this other rectangle right here. So let me go ahead and outline that. So let me use a different color. All right, so we have the width here, and we have the length here. Okay, and then we have the triangle. So let me go ahead and outline that as well. So we have the triangle right here, we have the base here, and then we have the height right here. Okay, so let's go ahead and see what we're looking at now. So there are some more adjustments to be made here because this base right here is in alignment with this base here. And notice that the base doesn't go all the way out here. So that means this 2 right here, this 2 centimeters must be subtracted from the 10 centimeters, right? Because the bases have to be in alignment, okay? Because this base extends all the way out here, but this base extends out here for the triangle. So let's subtract 2 from 10. And so the base here is 8 centimeters. That means the base here for the triangle is also 8 centimeters. So now we can go ahead and we can do our problem solving. So if we take a look at this first rectangle here, we have to find the length times the width. So length times the width. So 3 times 2 is equal to 6. Plus the area of the triangle, we have 1/2 times the base times the height. So 1/2 of 8 is 4. And 4 times the height of 1 is equal to 4. So this is equal to 4. So I'll place that right here. And then we have the area of this other rectangle, which is length times width, which is 8 times 6 equals 48. All right, so let's go ahead and calculate that. So we have 6 plus 4 is 10, and then 10 plus 48 is equal to 58. So the units here are centimeters, so our answer here is 58 squared centimeters, or 58 centimeters squared. So that's the area of this polygon. Okay, so let's go ahead and move on to another problem here. So here we have to translate the figure 4 units down and 3 units to the left. So I like to go about this by starting with the first point, which is A. And so I'm going to start at A right here at this point right here, and let me use a darker color so that way we can see. Okay, so starting at A, I'm going to translate the figure 4 units down. So that means I'm just simply going down 4 units, and then I'm going to go 3 units to the left. So this is a simple transformation, which is a translation. Okay, so I'm going down 4 units, 1, 2, 3, 4. Okay, and then from here, I need to go 3 units to the left. That's 1, 2, 3. So I have a point right here. And so this is A prime. So I'll put that right here. And then the next one is B. I'm doing the same thing. 4 units down. That's 1, 2, 3, 4, and then 3 units to the left. 1, 2, 3. So my point belongs here. So this is B prime. Let's go with C. 1, 2, 3, 4, and then 3 units to the left. We have 1, 2, 3, and that's right here. So this is C prime. And then last but not least, we have D. So we have to go down 4 units. So that's 1, 2, 3, 4, and then 3 units to the left. 1, 2, 3. So all you're doing is just following the directions, okay? So this is D prime. So all we have to do is connect the dots. So let's go ahead and do that. So we have this the A to B to C to D, and then from D to A. Okay, so that's your translation. All right, so let's go ahead and move on to the next question. And this question is asking us, which of the following could be the measurements of 2 supplementary angles? Okay, so it's not saying that it really is, but it's asking us which could be. All right, so first of all, what are the measurements for supplementary angles? Well, 180 degrees. So let's take a look at answer choice A. And I can see already that this is not the correct answer because 5 plus 85 is simply 90. And we know that 90 degrees are complementary angles. Okay. And then we have 85 plus 85. So that's not correct. That's equal to 170, I believe. Let me see, 10, 16, 17. Yep. So that's incorrect. And then we have 72 and 108 degrees. Bingo, this is correct because we have 72 plus 108, which equals 180 degrees. And then D is not the correct answer because 102 degrees plus 98 is exactly 200. Okay, so answer choice C. All right, let's go ahead and move right along. Here we have a line segment on a coordinate grid, and it says Tasha drew a line segment on a coordinate grid. She plans to reflect the line segment over the y-axis. Graph the new line segment. So I'm just going to take a look at the y-axis, which is here, and taking a look at this line segment, I'm going to focus on this dot right here. I'm going to figure out how many units away it is from the original starting point here, and it's 1, 2, 3, 4. And so I'm going to start from this point here, start from here, and then I'm going to move over 4 units to the left this time because I'm reflecting over the y-axis right here. So that's 1, 2, 3, 4, and I'm going to place my new dot right here. And I'm going to do the same thing here. So that's what you want to do here. So that's 1, 2, 3, 4, 5, 6 from 2. And then I'm going to go 6 units to the left here, starting from here. 1, 2, 3, 4, 5, 6. And so this is the new line segment that Tasha drew. So I'm just going to connect the dots here. And there it is. So that's it for this particular problem. So let's go ahead and move on. Okay, so here we have a word problem. And let's see. Let me see what the question is asking. First of all, is asking which best describes the volume of the second prism. All right, so let's go ahead and look through the answer choices. The volume is 100 times the volume of the first. Okay, the volume is 50 times. Okay, so this is not that complicated as we can see, but let's read through the word problem. Tim has two rectangular prisms. the length of the second prism is 100 times the length of the first prism. The heights and widths of the two prisms are the same. Which best describes the volume of the second prism? So if they're the same, and it's saying that the length of the second prism is 100 times the length of the first one, well then we can do process of elimination and we can say that B, C, and D are not correct, right? Because it's saying the length of the second prism is 100 times the length of the first one, and the heights and widths of the two prisms are the same. Which best describes the volume of the second prism? Well, the volume is 100 times the length. The volume is 100 times the volume of the first prism. Okay, so answer choice A is the correct answer choice here. Okay, so let's go ahead and move right along. So with this problem, this says this figure is formed by a square and an isosceles trapezoid. What is the perimeter of this figure? Okay, so here we have this shape here and we're just looking for the perimeter. So I can see that this is a square, so that means this side is 12 inches. And this side is 12 inches as well. So I'm just going to calculate the distance around. So we have 12 times 1, 2, 3 sides that are 12 inches, which is 36. Plus we have 6 inches here. That means this side is also 6 inches. So that's 36 plus 46 plus an additional 2. That's 48. And then 48 plus 9 is, 48 plus 9, and that's 57 inches. So the distance around this figure is 57 inches, or the perimeter is 57 inches. Okay, so let's go ahead and move on to another problem. This one wasn't too difficult. Okay, so we have this question here, which is closest to the volume of the cone. So I'm looking at the word closest, so I know that it's not going to be exact. So I know there's some rounding that's going on. So let's go ahead and finish reading the problem. We have the radius of the base of a cone is 4 inches. The height of the cone is 9 inches. All right, so let me just go ahead and draw a simple cone here. And so it told us that the radius of the base is 4 inches. So we'll just draw that right here, place 4 inches here. And then the height of the cone is 9 inches. So we'll just place 9 here to represent the height. And we have to find out which is closest to the volume of the cone. Okay, so I have this formula here, V, which stands for volume, equals pi r squared times the height divided by 3. Okay, so we're just going to take and utilize this formula by plugging in our values that are known, and then we'll solve from there. Okay, so we have V equals, and then we have pi, which is approximately 3.14. 3.14 times the radius squared, and we know that the radius here is 4 inches. Bring up my exponent, and then that's multiplied by the height divided by 3. So the height here is 9. That's 9 inches divided by 3 inches. Okay, so let's go ahead and continue solving this, but let's perform order of operations. So we have 3.14 times 4 squared is simply 4 times 4, which is 16, times 9 divided by 3 is equal to 3. All right, so it doesn't matter in which order that we multiply, but I do know that 16 times 3 is equal to 48. So I have 3.14 times 48. So I'm going to go ahead and plug that into my calculator. So we have, 3.14 times 48. Okay, and so I'm getting 150.72. So that means that the answer is letter choice C, 151 cubic inches. Okay, so let's go ahead and move on to the next problem. Okay, so this says one piece of a stained glass is transformed 3 times. Okay, so I can see that here. So it moved from here to here to here. So that's 3 times. Okay, what transformation was used to create this section of the stained glass window? Okay, so was this a dilation? It definitely wasn't a dilation, because a dilation is a change in the shape, whether it went from big to small or from small to big. So it's not answer choice A, so we'll go ahead and cross that out. Was this a rotation? Well, no, it's not a rotation, because a rotation is something that's going around like this, or even like this, right? So it wasn't a turn. Reflection, no, reflection just shows that it would be on the opposite side, so these would be on the opposite sides, right? But it is a translation because it was a slide. So if you can see here, it was like a slide, like a movement. Okay, so the correct answer is D. All right, so let's move on to the next problem. Okay, so this says a 3-dimensional figure is constructed using identical cubes. One view of this figure is shown below, which is right here, which could be the front of this 3-dimensional figure. Okay, so just take a look at this front side and make believe that you're standing right in front of it. So if you're standing directly in front of this, you're not going to see this top part. You're not going to see this part. So just count 1, 2, 3. So that's 3 going down, and then 3 going across. 1, 2, 3. So which one matches that? So we have 1, 2, 3, and then 1, 2, 3. So it's answer choice A, but it's not any of the other choices. It can't be any of the other choices, because if we look at B, this is 1 too many, 1, 2, 3, 4. So you can just stop right there. And so taking a look at C, you can count 1, 2, 3, 4. So there's 1 too many here, although we have the same amount in the bottom. It still doesn't fit this. Take a look at D. We have the same amount going up, 1, 2, 3, and across 1, 2, 3. But notice this extra piece right here, although we have that on the side, you're not going to see this when you're just standing upright, just looking directly at this, okay? So just, if it'll help you, take a look at the shaded regions or the shaded areas, and that'll help. So that's enough for this particular problem, and A is the correct answer. So let's move on to the next one. Okay, so here this says a wire connects the top of a flagpole to the ground as pictured below. Which is closest to the height h of the flagpole? So first thing I want to do is go ahead and take a look to see what is pictured below here. I see that it is a triangle with a flagpole. I see that height is expressed as h, as is stated here in the question. And then I've noticed the right triangle, and notice that this right triangle is across from a value of 12. So this is letting me know that this is the hypotenuse, which when I hear the word hypotenuse, I think Pythagorean theorem. So I'm actually going to set up that formula. So we have a squared plus b squared equals c squared. Okay, and then I notice that I have a value of 3 meters here, 12 meters here, and then of course we do not know what the height is yet. That's what we're looking for. So I can actually say that this is C, and I can use this as, we'll call this A. And then we'll say that H is B, okay? So let's go ahead and fill in what we do know. And we know that this is going to be an approximation simply because it's asking which is closest to the height. So it's not going to be exact, so we know that. All right, so we have a squared, which is 3. So we'll place 3 squared here. Plus b squared, we do not know what that is. And just so we're not confused, we'll just place h here, h squared, since we're looking for h. And that's equal to c squared, which is 12 squared. Okay, so we have to square 3, which is 9. We still have our h squared. We have to square 12, which is 144. And so now I can go ahead and remove the 9 on both sides. So that way we have h squared alone. The 9's cancel out, so the h squared is alone. And 144 minus 9 is 135. So now this is where we need to take the square root, because remember, we're looking for h, or the height, okay? So the opposite is taking the square root. And so this is left with h equals, and the square root of 135 is about, I'll say approximately 11.61. Okay, and so I'm looking at my answer choices, and I can see that I can eliminate A, B, C, and the correct answer would be D, because if I actually rounded this to the nearest whole number, that's actually equal to 12 meters. So the correct answer in this case is answer choice D. Okay, so that's all we have for this lesson. I hope it was helpful, and thanks for watching.